Hello friends, we all know that the NLC India Limited has conducted the GET exams in the month of November for various branches. So here we will discuss the answer keys and detailed solution of the electrical branch. Today it has released the answer keys. If you want the answer keys, you can go to the link in description to check your responses. So let's start. So I will be covering the 80 questions of electrical professional knowledge part, and we will see one by one each and every questions. So first question, which of the following are the variable losses in induction motor? So it is asking which are the variable losses. So obviously copper loss is one of the variable loss, and another loss will be stray load loss. So answer is the third option. So next question, it is saying the delay time for the system having unit step response Ct equal to 1 minus e to the power minus 2t is dash. These are the options given. So if you see, Ct is written in this format. Ct is equal to 1 minus e to the power minus t by tau. We know that rise time is the response time taken by the response to reach 10% to 90%, and rise time has the formula pi minus theta by omega d, where theta is this value. So if you apply the value, we will finally get the answer. So answer is third option. Next question, it is saying which of the following is a false statement considering common collector amplifier? So you can see here common base, common emitter, and among common collector, the voltage gain is very low for common collector and very high for common emitter, around 500, and for common collector it is very low. So it is asking what is the false statement. So here it is given high voltage gain for common collector, so it is a false statement. So the option is fourth option. Next question is, let Vs be the sending end voltage. So Vs is sending end voltage and the receiving end voltage Vr under no load condition for short and long transmission lines are respectively. So for short transmission line Vr will be Vs, and for long transmission line Vr will be greater than Vs, which is nothing but the Ferranti effect. So the first option is the correct option. Next question, the voltage is V equal to 200 sin 314t is applied to a single phase transformer winding at no load test. The current is given as this: I equal to 10 sin 314t minus 60 degree. So among V and I, if you see, the phase difference is 60 degree. So we know that power equal to core loss equal to Vrms Irms cos phi, where phi is equal to 60 degree. So if you apply the formula, so it will be 200 by root 2 and 10 by root 2 into 1 by 2 equal to, finally we will get 500 watt. Why 200 by root 2? Here Vm is equal to maximum value is equal to 200 given. So if you want to calculate RMS value, you divide it by root 2. So 200 by root 2. Similarly, you can calculate for the IRMS. Next question is, in a 400 by 230 single phase 50 Hz transformer, the primary winding is connected to 400 volt. Then it is asking EMF per turn in the primary divided by EMF per turn in the secondary. So we know that E1 by E2 equal to N1 by N2. So E1 by N1 equal to E2 by N2. E1 by N1, what is E1 by N1? EMF per turn. We call it EMF per turn. So in transformer, EMF per turn in primary and secondary are equal. So the ratio will be 1. So the answer is 1. Next question, if the number of poles in a lap wound generator is quadrupled, then the generated EMF will dash. So we know that the formula for EMF is this. So you can say EMF is proportional to P and inversely proportional to A, where A is the parallel path. And we know that for lap P equal to A. So finally we can say E remains the same. If you increase pole, if you increase the number of poles, it will not affect the value of EMF. So the answer will be EMF will be remain same. Next question, the SCR triggering method in which the junction temperature can be maintained at low value. So it is asking about which method of triggering the SCR the junction temperature is maintained at low value. So what is the ideal method of triggering SCR? Gate triggering. Ideally we use gate triggering where temperatures are maintained at low value. So the answer will be gate triggering. Next question, it is saying D is the duty ratio, the input and output relation of a buck converter and boost converter. So this is asking about the diode formula. For buck converter it will be V output equal to D into V in, and for boost converter V out equal to 1 by 1 minus D V in. This is the diode formula based question. Next question is saying in synchronous machine if pitch of the coil is R minus 1 by rth fraction of full pitch, then so if you see here, if this is north pole and this is south pole, this is one full pitch north to south, one full pitch. So it is saying pitch of the coil is this R minus 1 by rth fraction of full pitch. So let's suppose it is reduced to 2/3 of the full. So 1/3 is the shorted part. So it is saying which harmonic can be eliminated from the induced EMF in the phase. As you know from the pitch factor formula, for third harmonics cos the pitch factor is cos 3 alpha by 2. So you can take the example of third harmonics here. So if R is here 3, R minus 1 is 2. So you can say if the synchronous machine pitch of the coil is 2/3 of full pitch, 2/3 of full pitch, 2/3 of full pitch, the third harmonics or the rth harmonic component can be eliminated. So the answer is the third option. Next question, it is saying hollow conductors and bundled conductors help in dealing with. This is the diode question and the answer will be corona. Next question, in power system there are 50 buses. So N is equal to 50 and slack bus is 1. Generator buses are 8, which is M. So it is saying by Newton-Raphson method size of the Jacobian matrix is the J matrix. The Jacobian matrix has what size? We know that this is the size of the J matrix 2n minus m minus 2 cross 2n minus m minus 2. So if we apply put the values of here the m and n here, you will get 90 cross 90. So the last option is the answer. This is the direct question from fuzzy logic. The truth values of fuzzy sets are dash. Answer is 0 or 1. Next question. For impedance, it is given 0.8 on base 50 MVA and 66 kV. So it is saying calculate the power unit impedance on the base 100 MVA and 33 kV. So we know that the per unit impedance value formula is Z per unit new equal to Z per unit old into MVA new by MVA old and kV old by kV new square. So if you put these are the old values and these are the new values. So if you put the values, you will get the first option. In next question, a circuit is given. It is showing that SCR is fired at 45 degree. The load voltage and current at omega t is equal to pi will be. So we know that if there is RL load, there is inductor in the load. So due to L, the load current will not be 0. Easily the load current will not be 0. So one can guess that the load current is 0 should not be there in the answer. So here it is written the load current is 0, so it will be not the answer. Here it is saying the load current is 0, so it is not the answer. And here it is saying both load voltage and load current are non-zero. Voltage can be 0, but current cannot be 0. So you can say only load voltage is 0. So this is the right answer. Next question, relate reluctance with the following. We know that reluctance is nothing but MMF divided by flux. So if you write the units, ampere turn divided by Weber. So it is asking only the unit part. So this is the answer, ampere turn per Weber. Let's see the next question. The question is saying zero inductance and infinite resistance are features of zero inductance and infinite resistance. If you take a open coil, you can see it is not connected to any source. So you can say L is 0 and R is infinite. If you connect the inductance to a source, you can say some value of L is there. You can predict the values of R also. So as it is not connected to any source, you can say L is 0 and R is infinity. So the answer will be open coil. Next question, it is saying IC equal to 16 UT is applied through a capacitor. The voltage Vc it is asking. So we know that Vc is equal to 1 by C IDT. So if you integrate the value 1 by C integration of 16 UT, so 1 by C 16 by C, what is the integration of UT? Simply T. So first option is the answer. Next question, it is saying in an SCR with 4 layers represented as shown in figure, which are the layers are equally doped. So it is saying what are the equally doped regions. So this is anode, this is cathode, and this is gate. So you know that anode and cathode are equally heavily doped. So you can say anode and gate are equally heavily doped. So anode here P1 and gate P2. So you can say P1, P2 is the answer. Question number 20, it is saying an op-amp has common mode gain of 0.01 and differential mode gain of 10 to the power 5. So its common mode rejection ratio will be, we know that CMRR, common mode rejection ratio, equal to AD by AC. So if you take put the values here, it is coming 10 to the 5 divided by 10 to the minus 2. So it is it looks like the answer will be 10 to the 7. So I have a doubt of this question. What will the answer? According to you, what will be the answer? Please let me know in the comment. This 20th question. They have provided this answer 10 to the minus 7, but I think the answer will be 10 to the 7. So what do you think? Let me know in the comment. So next question, three capacitors 10 microfarad, 20 microfarad, 30 microfarad are connected in parallel to a 150 volt sinusoid. Then identify the correct statement. So if we know that if capacitors are connected in parallel, maximum voltage will be across the minimum value of the capacitance. So the option 1 will be correct. Maximum voltage will be applied across the 10 microfarad capacitor. Next question, question number 22. It is given op-amp as an integrator. It is given an op-amp integrator. So it is saying the output of the circuit is triangular wave. So output is saying is a triangular wave. Then the input of the circuit must be. So it is saying what is the input of the circuit. We know that step signal square signal. If you integrate it, it will be the triangular signal. So the answer will be square wave. Input will be square wave. So next question is saying a three-phase induction motor synchronous speed is this. Induction motor synchronous speed is this. Then the motor speed can never be equal to. We know that induction motor never reaches its synchronous speed. So it has already given the synchronous speed. So the answer will be third option. Next question, it has given a transformer primary winding. It has shown the primary winding, secondary winding, and it has shown the turn ratio N1 by N2 is 1 by 2. So it is saying the magnetizing current run is 1 ampere and the secondary current is 1 ampere. Then the primary current is. So it is asking about what is the primary current, and it is saying neglect the core loss and leakage reactance. From the transformer performance equation, if you see the transformer performance equation, we write like this: I1 vector equal to I0 vector plus I2 vector, where I1 is the primary current, I2 is the secondary current, and I0 or I0 is the no load current. So it is saying in the no load current you neglect the core loss component. So only magnetizing component will be there. So finally, I1 vector equal to I mu plus I2. So secondary current is 1 ampere. If you transfer it to the primary side, it will become 2 ampere. We know that I1 by I2 equal to N2 by N1. So 1 ampere secondary, if you transfer to the primary side, it will become 2 ampere. So if you finally add them, I1 equal to or I1 mod equal to 1 square plus 2 square. It is not simply addition, it is vector addition. That's why if it is asking about the magnitude, you have to take the square root, square it and take the root over. So the third option is the right answer. This is the important point here. The transformer performance equation, we write I1 equal to I0 plus I2. And here it is saying the coulomb component is absent, so you can take the magnetizing component, and here magnetizing current is given. So the third option will be the answer. Next question, it has given two inductances, so it is asking the net inductance of the circuit of the above each. We know that mutual inductance here M is aiding, the mutual inductance is aiding, so the net inductance will be L1 plus L2 plus 2M. Here the mutual inductance is opposing, so you can say L equal to L1 plus L2 minus 2M. So as per the question, if you see the mutual inductance is aiding, so the third option will be the answer, L1 plus L2 plus 2M. Next, the graph is shown is here, so it is asking the graph represent a signal defined as dash. Which signal it is representing? We know that exponential, what is the exponential graph? This is the exponential graph. This is a graph of e to the power at, and this is the graph of e to the power minus at. So it is similar to this graph. So you can say xt is equal to e to the power at where a is negative. If a is here negative, it will be like this, e to the power minus at. So the answer will be second option. Next question, for a given circuit breaker, identify the correct relation. So it is the direct relation, that formula based question. Answer is the first option, making capacity is equal to 2.55 symmetrical breaking capacity. Next question, saying sum of instantaneous powers in a three-phase in the three phases in a three-phase system is dash. Options are these. So we know that the power, instantaneous power, always same in the three phase. Instantaneous sum, the sum of instantaneous power always remains same. You can see in the figure it is written constant power due to three phase supply, P is equal to PR plus PY plus PB. So the answer is the third option. Next question, in an induction motor, the ratio of power developed by the motor to the air gap power is 0.96. Air gap power and power developed by the motor. So we know that PD equal to 1 minus S PG or PAG. PD power developed is equal to 1 minus S P generated, power generated. So it is saying power developed by the motor PD divided by PG equal to 0.96, which is nothing but 1 minus S. So what is S? S will be 0.04, or you can say 4%. So the slip will be, percentage slip will be 4%. So second option is the right answer. Which of the following combination of three-phase transformer is rarely used due to harmonic consideration? We know that delta star and star delta are mostly used, so it is asking which is rarely used. Answer will be star star. Next question, it is saying a capacitor C is connected to a single phase 50 Hz to 240 volt AC supply, draws a current 24 ampere. What would be the current if the voltage applied is changed to 200 volt at 60 Hz? So it is given the 240 volt AC supply and current drawn is 24 ampere. When the frequency is 50 Hz, now frequency is changed to 60 Hz and voltage is also changed to 200 volt. So what would be the current? We know that capacitor current equal to I equal to C dV by dt. If you take 1 by t as frequency, you can write I equal to C dV df or delta V delta f. So if you put the value here for the first part, 24 equal to C into 240 volt into 50 Hz. Now you can take what is C? C is this. C is equal to 24 divided by 240 into 50. Now it is asking what is the current, means I new value. What will the I new value? So if you again write C V new F new, if you put all the values here, you will get 24. So the last option is the right answer. Next question, if ut equal to 1 for t greater than 0 and equal to 0 for t less than 0, the value of the function this at t equal to 0.8 is dash. So you in place of t you put 0.8. If you put 0.8, the equation will be like this: 5 u of 0.8 minus 4 u of minus 0.8 plus 0.8 u of 0.2. So it is saying, we know that also step signal is like this. Step signal is like this. So this is time t, this is ut, for this is 0 and these are minus t value, negative value. So for positive values of t, it will be 1. For negative values of t, it will be 0. So here 0.8 is positive, so 5 into 1, minus 0.8 is negative, so 0. 0.2 is positive, then it is 1, so 0.8. So finally it will be 5.8. So let's see the next question. The next question saying, in a clipper circuit, DC source is set to 0 voltage. So this is a clipper circuit, so this DC source is set to 0. That means it is disconnected or short circuited. Then the circuit acts like a dash. The answer will be rectifier, because if you set the DC voltage source to 0, our graph will be shifted to here. It will be like this. It is nothing but a rectifier output, so the answer will be rectifier. Next question, it is saying, identify the false statement considering the current transformer and potential transformer. We know that these are not power transformers, these are instrument transformers. So the first option is false. So first option is the answer. Next question is saying, the sampling frequency of analog signal st is equal to 4 sin 300 pi t plus 2 cos 50 pi t should be. So according to sampling theorem, we know that a continuous time signal can be represented in its samples and can be recovered back when sampling frequency fs is greater than or equal to twice of the highest frequency component. So fs should be greater than or equal to twice of fm maximum frequency. So if you see here the frequency maximum, you can see it is 300 pi, so obviously it should be greater than 300 hertz. So if you see the options, only two option is correct. The option 2 is correct. Coming to the next question, it is saying the output voltage waveform of a rectifier is shown in the figure. The average output voltage is. So we know in case of SCR rectifier, this is the output voltage equation. V0 equal to Vm by 2 pi 1 plus cos alpha. What is alpha here? Alpha is 30 degree. If you put all the values, this will be the answer. Last option. Next question, it is saying find average load voltage of the rectifier circuit if the device is switched on at alpha angular angle. So this is the rectifier circuit. We know that output voltage V0 is equal to Vm by 2 pi 1 plus cos alpha. So we know that Vrms equal to Vm by root 2. So if you want to write Vrms here, you substitute Vm value. What is Vm? Vm is equal to root 2 into Vrms. So you can write V0 equal to root 2 Vrms divided by 2 pi 1 plus cos alpha. Root 2 and 2 will be cancelled, and the denominator root 2 will come. So the answer is second option, Vrms by root 2 pi 1 plus cos alpha. Next question, it is saying in 3-phase power measurement by 2 wattmeter method, the 2 wattmeter reading are equal 300 watt and 300 watt. So the power factor should be dash. As we know, W1, if W1 equal to W2, power factor should be unity, cos phi equal to 1. So the answer will be unity power factor, first option. Next question, the incipient faults in a transformer are identified by dash. Incipient faults means internal faults are identified by gas actuated relay, or you can say Buchholz relay. So the option is the last option. Here it is given size of the bus admittance matrix of a single line diagram shown in the figure below. So what will be the size? So you can see 4 buses are there. This is 1, this is second bus, this is third bus, this is fourth bus. So bus admittance matrix, it is asking what will the size. Answer he has given 5 cross 5. I think this is not the right answer. The right answer should be 4 cross 4. What do you think about this question? Please let me know in the comment. I think 4 cross 4 will be the answer. Next question, it is saying what is the balanced condition for the given bridge. As we know, if you balance the bridge, it should be this branch into this branch equal to this branch into this branch. So you can say the third option is matching. Z1 into R3 equal to Z4 into R2. Next question, a series LCR circuit is resonant at 100 kHz. So omega naught equal to 100k kilohertz and has a quality factor Q is equal to 50. the lower half power frequency is dash. We know that Q equal to omega naught by bandwidth, and you can calculate bandwidth from here. Bandwidth will be 2K. So we know that this is the lower one and this is the upper one. So if total bandwidth is 2K, one part will be 1 and another part will be 1. So if it is here 100, it will be 99 here and it will be 101 here. So it is asking about the lower half power frequency. The answer will be first option. Next question, it is saying which of the following is invalid state and in 8421 binary coded decimal BCD. 8421 BCD, which is invalid state. So I think this is the right answer, 1110. Other are valid and this one is only invalid. Next question, it is saying over compound DC generator supplying load at 220 volt. If the machine terminal voltage is 220.2 when load current is 10, means one condition is this: when load current is 10 ampere, the terminal voltage is 220.2 volt. So it is asking at 600 ampere load current what will be the terminal voltage. So we know that for generator, this is the voltage equation: V minus Eg, V minus Eg, or V equal to Eg minus IARA. So for R, if you write for first, what you will write? 220.2 minus 220 divided by 10. I am writing like this. 220, what is 220? V minus Eg by IA. I am writing like this. This is the expression. So 220.2 minus 220 divided by 10 equal to x minus 220 by 600. If you solve this, you will get x equal to 232. So the third option is right. Next question, it is saying n is the number of times voltage rating is increased. Then for a distributor design, the conductor size reduced by dash of the original. This is that formula based question. The answer will be first option. Next question, it is asking what are the base load and what is the peak load. We know that base load is nuclear power plant, so peak load is diesel power plant and gas power plant. Diesel and gas power plant are peak power plants, peak load power plant. So 2B, 3B. So second option is the right answer. Base load power plant is nuclear power plant. Next question, for dash input, dash circuit produces dash output. So if you take the integrator type system, if you apply the step input, it will give you ramp output. If you apply the ramp input, it will give you parabolic output. So the last option will be correct. In hot wire instrument, the deflection is proportional to dash. Answer is first option. This is also diode formula based question. Next question, Z transform of unit step function is given by. This is also diode formula based question. So Z transform of unit step response, I have given it here. You can write 1 by 1 minus Z inverse, or you can write Z by Z minus 1. So the second option is right. So 50th question saying third harmonic component along with fundamental component. Air gap flux of alternator has both third harmonic component and fundamental component. And if the coils are short pitched by an angle alpha for fundamental wave, then pitch factor corresponding to third harmonic. We know that the pitch factor formula is cos n alpha by 2, where n is the harmonic. So for third harmonic, what will we write? Cos 3 alpha by 2. So the second option is right. Next question, it is saying a moving coil instrument has coil resistance R is this 10 ohm and can take maximum current of 100 milliampere. So if you calculate the voltage, it will be 1 volt. So it is again asking what modification is required in the instrument to measure the voltage range up to 500 volt. So we know that for voltage, to measure the voltage up to 500, it has to increase the range. So if you will connect a series multiplier here, series resistance here with proper value, it can measure up to 500 volt. And this is the formula, R series equal to m minus 1 Rm. What is m value? M is equal to 500, m minus 1 will be 499 multiplied by 10 equal to 4.99 kilo. So the answer will be first option. Next question saying the transfer function of below diagram is. Transfer function is nothing but the output Laplace by input Laplace. V out V0s by V in S equal to R by R plus 1 by Cs. So the answer will be the fourth option. Next question, for a given three-phase induction motor, stator output minus gross rotor output. Stator output minus power stator output minus rotor output is nothing but rotor copper loss. So the first option is the answer. In the method of defuzzification MEOM, it is also that question, mean of maxima. Next question, which of the following types of measuring instrument is used in measurement of both AC and DC quantities? It is also a direct question and easy question also. So the dynamometer type will be the answer. Next question, it is asking armature of a three-phase alternator has 240 slots and armature has 8 poles, and so its distribution factor is, we know that this is the formula for distribution factor, KDR is equal to sin R m beta by 2 m sin R beta by 2. So if you calculate slot per pole per phase, this will be the answer, sin 30 by 10 sin 3 degree, where R beta by 2 you will get at as 3 and m is 10. Let's see next question. Dash is present between air preheater and induced fan in a thermal power plant. This is also a direct question. The answer will be electrostatic precipitator. Next question, power MOSFET is a dash device. It is also a direct question. The answer will be voltage control device. Next question, it is asking how is the relation between charging reactance X, C and length of the line L are connected. So you can see here charging current I equal to V by XC, where XC equal to 1 by 2 pi FCL. So you can say XC is inversely proportional to L. So the answer will be first option. Next question, it is in the list 1 it is given damper bars, rotor bars, commutator, and in list 2 it is given DC machine, synchronous machine, induction machine. So we know that damper bars are in synchronous machine. If you see the silent pole construction, silent pole of a synchronous machine, here the damper bars are provided. So damper bars are for synchronous machine. Commutator is obviously for DC machine. So R is for 1. So the option is third option. Next question, it is saying a boost chopper chops 3 voltage DC voltage to produce an average output of 18 volt. So V0 is 18 and V in is 3. From the formula we know that for boost chopper, boost converter, this is the formula V0 by V in equal to 1 by 1 minus D. So you can write 18 by 3 equal to 1 by 1 minus D. From this you can find D equal to 5 by 6. So this is the answer. Next question, it is saying the reactance of a generator is given as 0.3 on its nameplate. Base MVA and base kVA are given is this. So these are the old values. Find the new per unit reactance using new base of 25 kV and 200 MVA. As we have already discussed, Z per unit new equal to Z per unit old into MVA new by MVA old into kV old divided by kV new square. So if you put the values here, it will be 0.3. what is new value of MVA? 200. what is old value? 400. what is new value of kV? New kV is 25. what is old? 20 square. Finally we will get this answer. Next question, the transfer function of a system with input RT 1 plus e to the power minus 3t and response Ct equal to e to the power minus 2t each. So if you inverse Laplace it, or if you find the Laplace of this, you will get this Rs equal to 1 by s plus 1 by s plus 3. And if you Laplace this, Ct, Cs will be this. So we know that transfer function is nothing but output Laplace by input Laplace. So Cs by Rs equal to 1 by s plus 2 divided by 2s plus 3 divided by s into s plus 3. So if you solve this, you will get this answer. So the first option is the correct option. The law in mechanical system which is analogous to Kirchhoff's law in electrical system. We know that the analogy we have seen in the control system, force, torque, voltage, force, torque, current. These analogies are nothing but D'Alembert's two Kirchhoff's law analogies. So the option will be first option. Next question, it is asking the inverse Laplace transform of xs equal to 2 by s into s plus 1 into s plus 2. So if you partial fraction this, you will get 1 by s plus 1 by s plus 2 minus this you will get. Then you can easily find the inverse Laplace of this. So you will get this option. Then it is asking the number of iterations required to reach convergence in Gauss-Seidel method of load flow analysis are dependent on the size of the system and increase with increase in size of the system. We know that in Gauss-Seidel method the number of iterations are quite large and it takes more time to reach for the convergence. So as you increase the size of the system, the number of iterations will be increasing. So the third option is the right answer. Then it is asking in next question, the magnetic energy stored per unit volume is dash. We know that half into P into H. So this is the answer. P value is half, 0.5. Second option. Next question, it is saying identify the bridge network shown the above. This is also diet question. The answer will be Wine bridge. Next question, it is asking which one of the following generalized constant of transmission line are equal. We know that for nominal t, this is the ABCD parameters, and for nominal pi, this is the ABCD parameters. You can see here A is always equal to D. A is always equal to D. So the second option is the right answer. In polyphase AC circuits, the phase sequence RYB is same as. So if you draw a diagram like this, RYB, the phase sequence, next RYB, next what will come R, next what will come Y. You can see here RYB is nothing but YBR also. So the last option is the correct answer. Next question, identify the circuit based on the working principle. So here you can see two thyristors connected back to back and a voltage source is given, AC voltage source is given, load is RL load. So it is nothing but a SC regulator. Next question, identify the correct statement from the list given below. Scott connection transformer. We know that Scott connection transformer can transform 2-phase to 3-phase and 3-phase to 2-phase also. So 1 and 2 are correct. So the last option will be the answer. Hysteresis loss in electrical machine is typically given as. So what is the hysteresis loss? It is also diet question. KHB max into F. This is the right answer. Next question, it is saying 400 volt DC series motor develops shaft torque of 200 Newton meter at 80% efficiency while running at 1200 RPM. So we know that this is the formula for torque. If you put every value here, you will get finally I value as 25 pi. Here I have written P as E into I. And if you apply the efficiency also, you should multiply in numerator. So 25 pi will be the answer. Next question, it is asking which of the following is not true with respect to hot wire instrument. This is also a very direct question. So the second option is right. It's not correct. They have very low power consumption. Why it is not correct? Because the hot wire instrument are known for very high power consumption. So it is not true that they have a very low power consumption. So the second option is incorrect or false statement. Identify the false statement. Next question. So if you see the statements, if you see the second statement, it is saying speed of DC motor can be controlled by variation of angle of brush shift. We have seen that speed of DC motor can be varied by armature circuit resistance or armature voltage or field current. We have never seen that by angle of brush shift the speed of DC motor can be varied. So the second option is incorrect. Next question, it is saying with usual notation used for dielectric V equal to this expression represent test. This is also a direct question from EMFT. The answer will be Bohr's law. Next question, it is saying which of the following statement is wrong with reference to parallel operation of alternator. So alternator parallel operation always give better efficiency. So it will never give you poor efficiency. So the option 1 is the wrong option. Next question, it is saying the value of unit impulse function delta t for t greater than 0. We know that what is the graph of delta t. This is the graph of delta t. This is the graph of delta t. Only at x equal to 0 it is 1, otherwise it is 0. So it is saying for t greater than 0, what is it? What is the value of delta t? 0. Answer will be 0. So final question, it is asking two coils are given A and B 1000 ton each, and it is line parallel plane such that 90% of flux produced by one coil links the other. So it is asking the value of K. We know that K value is nothing but M by root of L1 into L2. So if we apply the formula here, we can find out K equal to 0.9.